Hello students, this is Ramesh Kumar Polepalli. Today I am going to explain you about Ohm's law. The relationship between potential difference across the ends of the conductor and the current passing through the conductor can be explained by using this Ohm's law. Materials required for this activity are battery eliminator connected with two wires, positive terminal of the battery eliminator is connected with a nichrome wire. Across the nichrome wire, we connected a voltmeter. From the point where we connected nichrome wire and voltmeter, we took another connecting wire for connecting an ammeter. So we know ammeter is connected in series with the switch. Here we used plug key as a switch. Another terminal of the plug key is connected to the battery eliminator. This completes the circuit setup of Ohm's law. Instead of connecting all these things, we have a complete Ohm's law setup. In this setup, we have all the voltmeter, ammeter and battery eliminators. All are there embedded in this system. By connecting nichrome wire and switching on the circuit, we can see the relationship between current and potential difference. Now by adjusting the knob, I am connected 1.5 volts potential difference across that nichrome wire. You can observe the current which is 16 milliamperes are shown in the ammeter. Now by adjusting the knob of a rheostat, I am increasing the potential difference across the nichrome wire which is to 3 volts. You can observe the voltmeter. For 3 volt potential difference across the nichrome wire, we can see the current in the ammeter which is around 32 milliamperes. You can note down these values in the table provided in the lab activity. Now I am adjusting the potential difference across the nichrome wire to 4 volts. You can see the potential difference in the voltmeter, that is 4 volts. Now you can see the current reading. The reading of the ammeter shows the current which is around 40 milliamperes. Note down these values in the table. Now I am adjusting the rheostat towards 5 volts across the nichrome wire. You can see that thing in the voltmeter. With this 5 volts, the current reading can be seen in the ammeter. You can see the current reading which is around 50 milliamperes. By the values what you have noted down in the table, you can find out the ratio of V to I in each pair of potential difference V and current, and draw the graph between V and I. You can see the graph, VI graph, what we found here is a straight line that passes through the origin of the graph, and the V by I ratio is also same for each case. By observing all these observations, we can find that the potential difference across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, providing its temperature remains constant. This is called Ohm's law. With this Ohm's law, we can say V is directly proportional to I and V by I is equals to constant. The constant what we found is resistance. Resistance is the property of conductor to resist the flow of charges through it. SI unit of resistance is ohm. According to Ohm's law, R is equals to V by I. I is equals to V by R. This equation shows that current through a resistor is inversely proportional to its resistance. In many practical cases, it is necessary to increase or decrease the current in the electric circuit. By using Ohm's law, it is possible. Thanks for watching this video. For more videos like this, please subscribe my channel PRK Physics 369. Thank you.